They told us the room hadn't been touched in decades, suspended in time like a cathedral of thought. The shelves stood sentinel, still lined with his original volumes of physics and philosophy, their spines weathered by years of contemplation. Chalk dust clung to the blackboard like fossilized equations, remnants of a brilliant mind wrestling with the deepest mysteries of existence. But it wasn't until that sweltering summer of 2004, when Princeton's maintenance crew began their methodical structural work on the east wing of Fine Hall, that they uncovered something extraordinary, something that had been deliberately hidden for nearly half a century beneath the floorboards of Albert Einstein's final office. There, embedded in the foundation like a time capsule of secrets, lay a sealed steel-plated compartment. No lock adorned its surface, no identifying label marked its purpose. Only a simple copper plate, green with patina, bore witness to its contents through a singular inscription etched in elegant German script: Zu öffnen, wenn die Zeit reif ist. To be opened when the time is ripe. The weight of those words would soon prove prophetic, for what lay within would challenge everything we thought we knew about the man who gave us relativity. Inside the compartment, wrapped in oil-treated canvas like sacred relics, rested a slim, cloth-bound journal, its pages pristine despite the passage of decades. Beside it lay a spool of audio wire, the type used in early German magnetic recorders, possibly a Lorenz model from the turbulent 1940s. Scattered diagrams covered yellowed paper, notes written in both German and English, the handwriting unmistakably Einstein's distinctive script. But perhaps most intriguing was a sealed letter, addressed not to any individual but to an abstract concept itself. Dem zukünftigen Denker. It read in careful Gothic letters. To the future thinker, as if Einstein knew that only time would provide the proper context for his revelations. The contents of this journal have never before been made public, suppressed for nearly a century, perhaps from fear, perhaps from the anticipated ridicule of the scientific establishment. Yet now, for reasons that even we cannot fully comprehend, these documents have surfaced at a moment when humanity stands at the threshold of understanding consciousness itself. This is not a tale woven from mysticism or the threads of pseudoscience, but rather the authentic story of a man whose name has become synonymous with rationality, relativity, and the very mathematical architecture of our physical universe, revealing in his most private and vulnerable reflections a radical theory that consciousness may transcend the boundaries of mortal flesh. Albert Einstein drew his final breath on April 18, 1955, in the sterile corridors of Princeton Hospital. True to his lifelong aversion to ceremony, he had specifically requested that his body be cremated and his ashes scattered in secret, ensuring that no shrine could be built to deify his memory. Yet in the months preceding his death, those privileged to be in his inner circle began to notice a profound transformation, not in his mastery of physics, but in his approach to metaphysics. He spoke with increasing frequency of what he called the edge of things, as one colleague would later recall with a mixture of wonder and concern. Hours would pass as he stood motionless at his office window, gazing toward some invisible horizon, his lips moving silently as he recited lines from Spinoza, while his weathered hands sketched unfamiliar diagrams in the margins of scientific texts that had once seemed complete. The journal discovered in that hidden compartment confirms what had only been whispered among a carefully chosen circle of confidants, that Einstein, during the twilight years of his extraordinary life, had been conducting experiments that no university board would sanction, no institute would fund, working in absolute secrecy, driven by an obsession that consumed his final years. He was attempting something that bordered on the impossible, to measure the persistence of information itself after biological death. One passage from the manuscript strikes the reader with particular force, its words seeming to echo across the decades. Translated from his native German, Einstein wrote, "If energy cannot be destroyed, as our own laws dictate, and if consciousness, whatever its true nature may be, emerges from a specific configuration of that energy, then perhaps what humanity has always called the soul is not merely an invention of religious imagination, but rather a phenomenon of physics that we have simply failed to understand." The manuscript reveals Einstein's extensive private correspondence with fellow physicists, most notably with Erwin Schrödinger, whose own pioneering writings had begun to speculate about consciousness as a fundamental rather than emergent property of the universe itself. But Einstein ventured far beyond his colleagues' theoretical musings. Using modified versions of his own electromagnetic field equations, he developed a hypothesis that under very specific conditions, information might not only persist beyond biological death, but remain detectable through purely scientific means. not through supernatural intervention or mystical revelation, but through measurable electromagnetic signals that could be captured and analyzed. Between 1949 and 1953, working with the dedication of a man possessed, Einstein had apparently constructed a crude but ingenious prototype of what he termed a Resonanzkammer, a resonance chamber designed to isolate electromagnetic signals from the chaos of environmental noise. This device, housed in secret within a sub-basement beneath the Institute for Advanced Study, represented the culmination of years of theoretical work. According to his meticulous notes, the chamber was constructed with layers of copper, lead, and magnetite, creating an electromagnetic sanctuary shielded from radio interference and the electronic chatter of modern civilization. At its heart, suspended like a spider's web, hung a delicate metal coil, an induction receiver calibrated to detect the subtlest fluctuations in the Schumann resonance, that natural electromagnetic heartbeat of our planet. Einstein believed with growing conviction that if consciousness possessed a measurable frequency, if it was indeed what he theorized as a standing wave existing in higher-order dimensional space, then under conditions of extreme isolation, its echoes might become detectable, particularly during those profound moments when biological processes finally cease their eternal dance. Then came the experiment that would haunt Einstein's final years. Through careful arrangement, he had formed a quiet collaboration with Dr. Otto Reitman, a Princeton physician whose work in the hospital's end-of-life care unit was characterized by both competence and absolute discretion. Together, they coordinated what could only be described as an ethically complex but meticulously documented study involving terminal patients who had volunteered to spend their final hours within the resonance chamber. Their vital signs were monitored from outside the chamber through remote sensors, while audio recording equipment and electromagnetic detection instruments maintained continuous vigilance over their transition from life to whatever lay beyond. The results, as Einstein wrote in increasingly shaken handwriting, were inconclusive but deeply troubling. Several hours after clinical death had been pronounced, in more than one documented case, the chamber's sensitive receivers detected brief but unmistakable bursts of structured electromagnetic activity, signals that bore no resemblance to random background noise. The frequency patterns showed no correlation to any known environmental source, displaying characteristics that defied conventional explanation. In one particularly haunting instance, a repeating signal emerged from the silence. 5 distinct pulses followed by a pause, then 5 pulses again, continuing with mechanical precision for exactly 17 minutes before ceasing forever. In his journal, Einstein captured both his scientific excitement and his profound unease. "I cannot claim to know what this phenomenon represents, but I am absolutely convinced that it is not random. The signal demonstrates entropy reduction that appears inconsistent with normal thermodynamic decay. Yet I find myself hesitating to publish these findings, for I fear the world is not yet prepared to abandon its comfortable illusions, whether material or spiritual in nature." And so, faced with the magnitude of his discovery, he chose silence. The letter discovered alongside the journal urges that these findings be released only when what he calls the philosophical maturity of science has evolved sufficiently to accommodate such profound questions without immediate rejection. That moment, we believe, has finally arrived. We are sharing these revelations because our world has transformed dramatically since Einstein's time. Information theory, quantum cognition, and revolutionary advances in neuroscience are rapidly converging toward a new understanding of consciousness, but during those final years, as he penned these extraordinary pages, Albert Einstein stood utterly alone, silenced, not by any institutional pressure, but by the overwhelming magnitude of what he believed he had glimpsed beyond the veil of measurable reality. As he wrote near the conclusion of his first notebook, in words that now seem prophetic, "If we refuse to ask what lies beyond the realm of the measurable, then physics itself becomes not a compass pointing toward truth, but merely an elegant cage confining human understanding." Einstein's resonance, a refined voiceover script. Einstein had always harbored a profound suspicion of quantum mechanics, not because he questioned its mathematical elegance or denied its startling effectiveness, but because something deep within his scientific soul whispered that the theory remained fundamentally incomplete. His immortal words, "God does not play dice with the universe," have been mischaracterized through decades of popular interpretation as mere religious sentiment, when in truth, they represented something far more profound, a rebellion against the very notion of indeterminism itself. He believed with unwavering conviction that hidden variables, undiscovered layers of causality woven into the fabric of reality, awaited revelation by future generations of physicists. Yet in the leather-bound journal discovered beneath Princeton's hallowed halls, we encounter a different Einstein entirely. Still the rigorous scientist, still the eternal skeptic, but now something more. Wounded by the brutal machinery of war, scarred by exile from his beloved homeland, and haunted by existential questions that even the most elegant equations had failed to illuminate. In this vulnerable state, he began turning his legendary intellect toward the mysterious spaces that exist between the mathematical symbols, the silence between the notes of the cosmic symphony. His investigation into what he would come to call resonance began not as some desperate search for proof of an afterlife, but as yet another attempt to solve the puzzle that had consumed his thoughts since the 1920s, the unification of electromagnetism and gravitation into a single, coherent theoretical framework. The unified field theory represented his final, tragically unfinished quest for understanding. What proves most startling in his private notes is how Einstein began to speculate that his repeated failures to unify these fundamental forces might stem from a deeper, more fundamental misunderstanding of the very nature of dimensionality itself. The journal contains extensive references to his correspondence with Theodore Kaluza and Oscar Klein, whose revolutionary work had proposed the existence of a fifth dimension as the key to reconciling gravity with electromagnetism. Einstein wondered, in the quiet hours of his contemplation, what if consciousness itself operates within this higher dimensional space? He posed the question with characteristic directness. If gravity and light require a deeper substrate to achieve unification, could human thought itself be nothing more than a ripple propagating through that same mysterious medium? He began constructing mathematical models of consciousness, not as a mere product of neurological activity within the brain, but as a resonance pattern, existing within a multidimensional field that transcended ordinary spacetime. In his diagrams, sketched with increasingly shaky hands during his frequent hospital stays, we witness his attempts to map the human mind as a topological structure composed of loops, nodal points, and complex interference patterns that dance through dimensions we cannot perceive. This revolutionary idea that thought, identity, and memory might somehow persist as coherent waveforms led Einstein to explore the behavior of electromagnetic fields within closed systems, using entirely new methodologies. He returned to Michael Faraday's pioneering experiments with renewed purpose. He revisited James Clerk Maxwell's fundamental equations with fresh eyes. Yet he applied these classical foundations in strange, deeply speculative ways, introducing mathematical coefficients for what he termed phi space, a concept entirely of his own creation. Phi space, as Einstein meticulously defined it in his notes, represented a hypothetical frequency domain that existed orthogonally to conventional spacetime, accessible not through acceleration or direct observation, but through the subtle art of resonance itself. These explorations were not the confused ravings of a brilliant mind detached from rigorous scientific method. The underlying mathematics remained sound, elegant, and internally consistent. However, the implications proved nothing short of radical. In one particularly detailed series of calculations, Einstein attempted to model precisely what would happen to an organized electromagnetic pattern, such as a complex thought process, if the biological system generating it were suddenly and completely removed from existence. The mathematical results pointed toward gradual decay, yes, but not immediate dissipation into nothingness. Instead, the waveform appeared to persist for measurable periods, as if the pattern itself were somehow searching for a new receiver, a new home in the vast electromagnetic landscape of the universe. Einstein's notes at this critical juncture grow increasingly poetic, revealing a man grappling not just with equations, but with the deepest mysteries of existence itself. In one particularly moving margin notation, he writes with profound elegance, "Perhaps the soul is not an object to be observed and measured, but rather a process to be understood, a song played once by the universe, yet still echoing through the canyon of space-time, long after the instrument that created it has fallen forever silent." At this transformative point in his research, his experiments shifted dramatically toward the challenge of detection. He began working with a modified version of the Blumlein transmission line, a sophisticated device originally designed to generate high-frequency electrical pulses for military and communications applications. Einstein theorized that if human consciousness possessed a distinctive electromagnetic signature, successful detection would require an instrument tuned not to raw power or amplitude, but to the subtle patterns that might distinguish conscious thought from random electromagnetic noise. This insight led him to design what he called a contrapunktischer Empfänger, a contrapuntal receiver inspired by the musical principle that if the universe itself could be understood as an infinitely complex fugue, then perhaps consciousness represented a recurring theme that might continue to manifest even after its original source had been silenced by death. Working alongside Otto Reitman and a mysterious technician identified in the notes only as J.L., possibly Johannes Lingen, a wartime signal analyst whose expertise proved invaluable, Einstein assembled a crude yet remarkably sensitive receiver in the basement laboratory of his Princeton home. Unlike conventional radio devices of that era, this revolutionary instrument was tuned not to standard broadcast frequencies, but to detect minute fluctuations in low-frequency electromagnetic fields within carefully shielded enclosures. The signal resolution remained frustratingly poor, and the interference from ambient electrical sources proved immense and nearly overwhelming. Yet during several meticulously recorded trials, the research team detected genuine anomalies: sudden spikes in electromagnetic coherence, dramatic drops in signal entropy, phenomena that defied explanation through conventional ambient electrical activity. In one particularly compelling experiment conducted following the death of a test subject who had previously participated in extensive memory and language exercises, Einstein's sensitive receiver detected a distinctly rhythmic signal operating at precisely 7 Hz, modulated in carefully timed bursts over a 30-second period. Remarkably, this identical frequency had appeared prominently in the subject's EEG recordings during a complex memory recall task performed just days before their passing. According to Einstein's probability calculations, the odds of such a correlation occurring through pure coincidence were less than 1 in 10,000, a statistical significance that demanded serious scientific consideration. He writes with growing wonder, "If these mysterious signals truly represent remnants or echoes of consciousness, then we must ask the fundamental question: what substrate retains and transmits them through time? Is it simply the air around us, the electromagnetic field itself, or something far deeper and more profound, perhaps a hidden lattice woven beneath the very fabric of space-time?" In the final months of Albert Einstein's life, something extraordinary happened. The man who had spent decades unraveling the mysteries of space and time began to explore the deepest mystery of all: what happens to consciousness when the body dies? Hidden beneath his Princeton desk for nearly 70 years, a journal would emerge that challenged everything we thought we knew about the nature of existence itself. The pages reveal a shift in Einstein's thinking, from the crisp mathematical certainty that defined his career to something far more profound and unsettling.
In their place, dense handwriting filled page after page, as if a man were racing against time to document a revelation that could change our understanding of reality forever. The journal's most haunting section bears a simple title: Versuch mit Stimmen, Experiments with Voices. It begins on November 22, 1954, with an entry that would have seemed impossible coming from the world's most celebrated physicist. Einstein wrote that for the first time, he had heard something through his experimental resonance chamber that disturbed him deeply. Not noise, not signal, but what he described as a modulated waveform containing harmonic intervals that corresponded to human vocal patterns. He emphasized with startling clarity that this was not a hallucination. It was recorded, measurable, real. When the audio recordings accompanying the journal were finally digitized decades later, what emerged defied easy explanation. Low-frequency modulations punctuated by rhythmic pulses, and twice, something that hovered between a voice and a musical tone. Experts who analyzed these recordings could not definitively classify what they heard as either linguistic or mechanical. Yet spectral analysis revealed an acoustic signature completely distinct from equipment interference or background electromagnetic fields. It was something else entirely, something that challenged the very boundaries between signal and noise, between presence and absence. Einstein's description of what he heard carries the weight of poetry pressed into scientific observation. It came not as a word, he wrote, but as the form of a word, like the shadow of meaning, pressed into a medium that cannot speak. These words reveal a man grappling with phenomena that existed at the very edge of human understanding, phenomena that seemed to bridge the gap between the physical and the metaphysical, in ways that conventional science had never dared to explore. Driven by this initial discovery, Einstein began conducting further experiments, some with test subjects, others in complete solitude. He would spend hours within the resonance chamber, meditating on personal memories, attempting to create what he called a resonant imprint of conscious intention. When he later replayed recordings from periods when the chamber sat empty, he claimed to detect faint resemblances, fragments of tone, pacing, even phrasing that seemed to match his own inner speech patterns. He never claimed this as conclusive proof of anything, but he could not explain what he was hearing, and that inability to explain haunted him. The journal reveals Einstein's growing fascination with an obscure phenomenon from the 1930s known as the Rorty voices, strange audio signals detected by Latvian psychologist Konstantin Rorty on magnetic tape, believed by some to be voices of the dead. Einstein had previously dismissed these claims as pareidolia, the human tendency to perceive meaningful patterns in random stimuli. But now, confronted with his own inexplicable recordings, he began to reconsider everything he thought he knew about the nature of consciousness and its relationship to the physical world. Drawing upon information theory and Shannon entropy models, Einstein calculated the improbability of random static producing the phonetic structures he observed in his recordings. The odds, he determined, were astronomically low, unless, as he wrote with characteristic precision, the system is not closed. This simple phrase carried profound implications, suggesting that consciousness itself might operate according to principles that transcended the boundaries of conventional physics. One of the journal's most intriguing sections describes Einstein's meeting with a mysterious figure known only as M, believed by historians to be Max Planck's nephew, a wartime physicist who had conducted classified acoustic experiments for the German Navy. According to Einstein's meticulous notes, this man shared details of a phenomenon observed during submarine communication tests in the Baltic Sea. Unidentified harmonics recorded during periods of radio silence, often following the loss of crew members. These harmonics exhibited signatures that mirrored recorded human speech patterns at frequencies well below the range of human hearing, as if something essential persisted beyond the moment of death. From these observations, Einstein began to formulate a hypothesis that would have revolutionized our understanding of consciousness itself. He theorized that under conditions of isolation, pressure, and human trauma, certain regions of Earth's electromagnetic field might become imprinted with cognitive structures. Not ghosts in any traditional sense, but patterns, signatures, reverberations of consciousness that he termed Nachklang. This wasn't mysticism masquerading as science. This was Einstein applying the same rigorous thinking that had given us relativity to the deepest questions of human existence. Perhaps the most controversial passage in the entire journal reads like poetry written in the language of physics. The soul may not be an entity, but a waveform, not bound to a location, but to a pattern of coherence. If so, then death is not dissolution but decoherence. Einstein drew parallels to quantum entanglement, that spooky action at a distance he had once resisted but eventually acknowledged. He wondered whether consciousness might be entangled with something that exists outside space-time itself, something that persists even when the local biological node collapses at the moment of death. Throughout his final months, Einstein returned obsessively to one central metaphor that captures the essence of his revolutionary thinking. The body is the transmitter, but the mind may be the signal. The transmitter decays, but the signal, perhaps it propagates, perhaps it looks for a receiver. This elegant formulation suggested that consciousness might operate more like a radio broadcast than a biological process, with death representing not an ending, but a change in transmission frequency. In December 1954, just 4 months before his death, Einstein conducted one final experiment that would haunt readers of his journal for generations to come. He sealed his resonance chamber completely and left it undisturbed for 72 hours. When he returned, his instruments had detected a narrow-band signal lasting exactly 14 seconds, a low tone modulated once every 3.5 seconds, its frequency matching the harmonic overtone of the human vocal tract. The chamber had not been disturbed, the instruments were verified, and Einstein wrote only these chilling words: "I have no explanation." The journal's final pages dissolve into fragments, lines of poetry scattered between equations, philosophical musings intertwined with mathematical proofs. But the closing passage stands as Einstein's ultimate statement on the mystery of consciousness. If we ever build instruments sensitive enough, not to force answers, but to listen, we may find that we have never been alone. Not in life, not in death. Consciousness may be the only constant, the signal hidden in the noise. These words, written by one of history's greatest minds in his final months, suggest that death might not be the end of consciousness, but merely its transformation into something we lack the instruments to detect and the wisdom to understand. Einstein chose silence over sensation, integrity over recognition,
leaving us with questions that challenge the very foundations of what it means to be human in a universe far stranger and more wonderful than we ever dared imagine. In the twilight of his extraordinary life, Albert Einstein's hands trembled as they moved across the pages of his final journal, each word etched with the weight of a lifetime spent wrestling with the fundamental nature of reality. These were not the steady calculations of a young patent clerk who had once reimagined space and time, but the deliberate, sometimes illegible scribblings of a man approaching the ultimate mystery. The handwriting wavers between legible prose and poetic fragments, yet every word carries the precision of a mind that had spent decades decoding the universe's deepest secrets. Gone was the fierce determination to prove his theories to skeptical colleagues, replaced by something far more profound: the desperate need to share an epiphany that had fundamentally altered his understanding of existence itself. "The universe is not a machine, but a conversation," Einstein wrote in those final months, his pen moving with the rhythm of someone transcribing a revelation rather than constructing an argument. "Every atom sings, every field responds in harmonious dialogue. We do not live inside dead matter awaiting our own demise. We arise within a symphony that has been playing since the first moment of creation, and perhaps long before." By this stage in his intellectual journey, Einstein had abandoned one of science's most cherished assumptions: that consciousness was merely an emergent property of neural complexity, a biological accident in an otherwise mechanical cosmos. Instead, he had begun to entertain a possibility that would have scandalized his younger self: that consciousness might be woven into the very fabric of reality, as fundamental as the forces that bend space-time and bind atoms together. This transformation hadn't come through mystical revelation or philosophical speculation, but through the same rigorous questioning that had led him to relativity decades earlier. He revisited his famous debates with Niels Bohr, those heated exchanges about quantum mechanics that had once seemed irreconcilable, now viewing them through the lens of his evolving understanding. Perhaps Bohr was right in ways neither of us fully grasped during those passionate arguments in Copenhagen, he reflected with surprising tenderness. The act of observation may not merely collapse the wave function as we believed, but actively participate in its creation. Perhaps consciousness is not a passive spectator watching the universe unfold, but its co-author, writing reality into existence with every moment of awareness. Through this revolutionary lens, death itself transformed from an ending into a transition, not the final period of a sentence but a shift in authorship, a continuation of the cosmic narrative written on pages invisible to those still reading the current chapter. Einstein didn't claim certainty about what lay beyond the threshold of mortality, only that there existed compelling scientific reasons to suspect that something endures, that the intricate patterns of information we call a human life don't simply vanish without leaving some trace in the quantum substrate of reality. "I do not believe in personal immortality," he had famously declared in his prime, dismissing such notions as wishful thinking. But here, in these final contemplations, he offered a crucial distinction that would have profound implications. Immortality of the ego remains a delusion born of fear and vanity, but continuity of pattern, that is fundamentally a question of physics, of resonance frequencies, of conservation laws that govern all transformations in the universe. He drew upon the metaphor of a candle flame passed from one wick to another, neither identical to its predecessor, nor entirely different, representing a continuity of form that transcends individual vessels, while maintaining essential patterns across space and time. This concept wasn't born from romantic sentiment, but from his deep understanding of how information and energy behave at the quantum level, where nothing truly disappears, but only changes form according to immutable physical laws. Einstein's journal concluded with extended reflections on light itself, the phenomenon that had captivated his imagination from childhood wonder about riding alongside a light beam to his Nobel Prize-winning work on the photoelectric effect. "Light has always been our most patient teacher," he wrote with the reverence of a student who had spent his life learning from this fundamental force. "It travels through the apparent emptiness of vacuum, reveals hidden structures invisible to our senses, bends the fabric of time itself, and perhaps, in ways we are only beginning to understand, carries the final traces of our existence like faint images left on the photographic plate of the universe itself." His final complete entry, scrawled beneath an equation that would remain forever unfinished, captured the essence of his transformed worldview. Perhaps death represents the moment when the waveform of individual consciousness becomes coherent with something far larger, some field or dimension we have not yet learned to name or measure. The journal ends there, leaving behind questions that continue to echo through the corridors of modern physics. Today's scientists explore territories Einstein could never have imagined. Quantum entanglement operating within biological systems, zero-point field fluctuations, neural correlates of consciousness, and non-local information transfer that challenges our understanding of space and time. The artificial boundaries between mind and matter, once seemingly insurmountable, are slowly dissolving, as evidence accumulates that consciousness and physical reality are far more intertwined than previous generations dared to consider. Yet Einstein's final work remained buried for decades, suppressed not because it lacked scientific rigor, but because it threatened comfortable assumptions about the nature of reality and our place within it. The establishment preferred Einstein the rationalist, the clockwork universe builder, not Einstein the explorer of consciousness and cosmic connection. But in our current age, drowning in data while starving for meaning, his words return with the persistence of truth-seeking recognition. We're left confronting questions that refuse easy dismissal. If consciousness operates at specific frequencies, where do those patterns go when biological transmission ceases? If information truly cannot be destroyed, as physics suggests, what happens to the accumulated story of a human life once its primary transmitter falls silent? And if Einstein himself, a man guided by mathematics rather than mysticism, believed it possible to detect the imprint of thought beyond the veil of death, what other possibilities have we missed simply because we lacked the courage to listen? This was never intended as a ghost story, yet it remains profoundly haunted, not by supernatural spirits, but by scientific possibilities that challenge our deepest assumptions about existence. We're left with the quiet, stubborn resonance of Einstein's final question, one that refuses to fade into academic obscurity. What if death isn't the end of the signal but merely a handoff to frequencies we haven't yet learned to receive?